Hey everybody, sorry about the late notes video here. Got caught up a little bit grading tests and doing some of those things. But either way, here are the notes for today. We're going to start Unit 10, which is quadrilaterals. And specifically today, we're going to talk about quadrilaterals and trapezoids. So we're getting into a little more of a geometrical feel here these last two units. All right, so quadrilaterals, as we kind of mentioned in the last unit when we were talking about inside a circle, is any two-dimensional shape with four sides. Okay, so at the top here we have a couple quadrilaterals for you of all different shapes and sizes. I want you to go ahead and think about how many triangles, equal triangles, can each of these quadrilaterals be divided into, right? So if we're looking at equal triangles, we're talking about, you know, this first one, you have one here and one here where it's symmetrical, and you could say that those are equivalent triangles, right? Okay, up here, what about, maybe not even so much about equivalent, but more importantly, how many times can you draw a line from one edge to the other and it splits it into a triangle, right? So like if I go from here to here, that's still the same triangle. If I go from here to here, still the same triangle, right? So there are two in that one. Okay, let's try the same thing here. So go from one edge to the others. How many triangles can you split a quadrilateral into? Well, here's one, here's two. Okay, how about this one? Go from one edge, split it into a triangle, one, two, right? Even if I go from this edge to the other edge, it's still the same. Okay, and on this one, say we go from down here, okay, well that's one, that's two. And again, anytime I go from that same edge and try and draw it to another edge, it does not create a new triangle. So what hopefully you're noticing is that all quadrilaterals, when I go from one edge to all the other ones, will split the quadrilateral into just two triangles, no matter which edge you use. Okay, so what is the angle sum of a triangle, aka like how many degrees are in a triangle? Well, we know it's 180. So if a quadrilateral can only be split into two triangles from the same edge, how many degrees are in a quadrilateral? Pretty easy. What's 180 times 2? 360. All right, so let's talk about trapezoids. Trapezoids, by definition, are a quadrilateral with at least one pair of parallel sides. At least. It could have two pairs, but at least one. Okay, now we use a couple different things terminology-wise. Bases, okay, are the pair of parallel sides. No matter what, if I say it's a base of a trapezoid, so a base of a trapezoid, it's talking about the two parallel sides. And we represent that, remember, with those, with the triangles. So this means that these are parallel. So this is a base, this is a base. All right? And then the non-parallel sides are your legs. They're called legs. Okay? So, what are the properties of a trapezoid? Well, the properties are, number one, that bases are parallel. Okay, we just kind of said that. I can get my stylus to work with me here. And number two, so obviously here and here. Number two, that the leg angles are, actually I might erase this and write angles. Supplementary. There's that word again, right? Okay, so what that means is that, and we mean on the same side, by the way. Okay, so that means, for instance, that if this is A and this is B, that A plus B equals 180. Okay, so angle A and angle B equal 180 degrees. Okay, So there's another thing you need to know about quadrilaterals, and that's that they have a mid-segment. And this mid-segment, okay, is a line right down the middle of the trapezoid, okay? We call it the mid-segment because it's a segment in the middle, all right? So what it does is it cuts this in half, right? So these are equivalent to each other, okay? Now, sometimes you'll be asked a question. It says, like, what is the formula for a mid-segment? Well, the mid-segment, first of all, by definition, is a line that connects the midpoints of the legs. Okay? But the mid-segment formula, the length of the mid-segment is where you add up both bases and divide them by 2. So basically, it's the average of the distance, right? So we could say that this is base 1 up top and base 2 at the bottom, okay? So that's how you get the mid-segment. It's just a distance. All right, so what about an isosceles trapezoid? An isosceles trapezoid, as you remember with a triangle, isosceles, like eyes, so 2 of the same sides, it's got a trapezoid with congruent, or you might see this, legs, okay? So it means that this is congruent to this. This is still parallel, that's still parallel, okay? But what are the properties of it? Well, the properties are that they, of an isosceles trapezoid, is that they all it has all the same properties that a regular does, okay, which means, number 1, the bases are parallel, number 2, the legs are supplementary, right? So that doesn't go away. Now we're going to add on 2 more properties for an isosceles trapezoid, and that's that the base angles are congruent. So it means that, like, if this is A, B, C, D, then what we're saying is that these 2 are congruent and these 2 are congruent. Okay? And then lastly, diagonals are congruent. Okay? So diagonals look like this and like this. And basically they are the exact same. Okay? All right, so let's go through some practice problems here. The first couple, let's see. Find the measure of angle F, measure of angle G, and the measure of angle H. Okay, well, since it's a isosceles trapezoid, that means that these 2 are congruent. So angle H is 110. Okay, and just like any isosceles trapezoid, these 2 are supplementary. So 180 minus 110 gives us 70. So these are 70 degrees. And again, this one's congruent to this one, so this is also 70 degrees. So 70 and 70 degrees. Okay? Same thing here. It's an isosceles trapezoid, so that means this is 68 degrees. And 180 minus 68 gives you 112 degrees, which is what these are. Okay? All right. Find the value of the variable for in each isosceles trapezoid. Okay, so this is isosceles. We want to find the value. It looks like all that we have to look for is x. Well, we know this is isosceles. These are congruent, so we can just set them equal. X plus 5 equals 3x minus 3. Okay, so add 3, x plus 8 equals 3x, subtract x, 8 equals 2x, divide by 2, 4 equals x. Done. Okay, this one, let's see, we know that these Our supplementary, so this and this add up to 180. 6x plus 20 plus 4x equals 180. So that's 10x plus 20 equals 180. Subtract 20 gives us 160. Divide by 10 gives us 16. Okay, and then y, which is right here, y is equal to that. So 6 times 16 plus 20 gives us what? 36, carry the 3 is 96 plus 20. So that would be 114. No, 116. Duh. Okay, equals y. All right, so 2 answers for that one. Okay, this one, pretty simple. We got 2 congruent legs. One leg 7x, other one's 2x plus 5. Subtract. Okay, 5x equals 5. Divide by 5, x is 1. All right, find x and y in each trapezoid. Okay, so we want to know what's the outside distance of here, okay, and the outside distance of there. Well, we know they're both the same. All right, so we have a mid-segment. Okay, let's see. Oh, it wants to know, I'm sorry, this is find xy. It wants to know what is xy in each of these, the line. Well, so this is a mid-segment, so it's base 1 plus base 2 divided by 2. 7.5 divided by 2 gives me 3.75. Done. Okay, number 12. XY is the mid-segment. Mid-segment is base 1 plus base 2 divided by 2, which is 24, divided by 2, which is 12. Okay, and then the last one, base 1 plus base 2 divided by 2 gives me 21, which is 10.5. Okay. All right. So that's pretty much it. That's how you work with trapezoids, and that's our intro to quadrilaterals. Let me know if you have any questions, and I will see you guys on Monday.